Okay, today ke tlo thoma ka go dira di-corrections tsa homework e le gore e file yona. So from there, we'll be looking at sets and roots together with rationalizing the denominator and exponential equations. So I'm not gonna do, I get to these questions. I'm just gonna do the complex ones. Gonna do this one. Let me choose a pen. I'm gonna do number C and number F. Then on question number 2, I'll be doing number G and number H because obviously you can be able to do them and go for the corrections based on them. Or are you correct or not? So remember, the first question says show that. Immediately they tell you about showing that, you should know what you have to prove. This question says show that. So that means you have to prove. Immediately kara maths of a question where show that you know what in mind. You have to prove. That is what we have to. Then number C, we're given 2 to the exponent 2 of. Firstly, before I write everything, I don't want to rewrite this equation and whatever. But what I want to tell you is, immediately they show that we have to prove. And if you prove, kanji, you prove that the left-hand side is equal to the right-hand side. So in this situation, you have to ensure that you look at the complex side. The side a much complicated the solver to find what is in the right or what is in the left. So in number C, we see that the complex side is the left-hand side. Then we're going to focus on what? Left-hand side. Then from our left-hand side, we're going to say we're being given 2 to the exponent 2x minus 1 plus 4 to the exponent of x plus 1. This is the left-hand side. Then we have to solve this. Then we know what this one, we can break it down into 2 to the exponent 2x multiplied by 2 to the exponent negative 1. This is whereby we're applying the law that says if the bases are the same, we add the exponent. Plus, here we know that 4, if we write it in exponential terms, we're going to have 2 squared, then x plus 1. Then 2 to the exponent 2x multiplied by 2 negative 1 plus 2. We're going to multiply this with the 2. Then from here, we're going to have 2x plus 2. Then again, we come again and say 2 to the exponent 2x multiplied by 2 minus 1 plus. Then here, we're going to break this down using the law that says if the bases are the same as the exponent, it will be 2 to the exponent 2x multiplied by 2 to the exponent 2. Then immediately you see plus or minus in terms of exponents. When we're dealing with exponents and you see plus or minus, you should know that we have to take out what a common factor. Here the common factor is 2 to the exponent 2x and 2 to the exponent 2x. Then we're going to take them out and say 2 to the exponent 2x multiplied by 2 minus 1 plus 2 squared. Then here we know what 2 to the exponent 2x multiplied by this one. If we add them, we're going to find 9 over 2. 9 over 2. And if you can check, this is equivalent to what is in the right-hand side. Then we say, therefore, left-hand side is equals to right-hand side. Then we have proven number C. Then let's look at number F. Number F, again, we're looking at the complex side. If you can check, the left-hand side is more complex than the right-hand side. Then we're going to focus on left-hand side. Then here we're going to say we are given 4 multiplied by 3 to the exponent 1 minus x plus 3 to the exponent 2 minus x. Then here we know what here we have 4 multiplied by this one. If we break it up using the laws of exponents, if the bases are the same as the exponents, we'll get 3 multiplied by 3 minus x plus, if we break down this according to the law that I've just said, we find 3 squared multiplied by 3 negative x. As I said, immediately you see plus or minus sign in exponent, you have to know which you have to take out a common factor. Then here will be taking out a common factor of negative the rate to the exponent negative x. The rate to the exponent negative x multiplied by 4 multiplied by 3 plus 3 squared. Then we're going to calculate this part from the calculator. 3 negative x, then we'll get 4 times 3 plus 3 squared. We get 21. Then from here, we know quickly if a number has an exponent of a negative, then it turns into a fraction. Then we'll be having 21 over 3 to the exponent of x. If you can see, that is equivalent to what is in the right-hand side of the equation. Therefore, we conclude that left-hand side is equals to right-hand side. All of these questions, we're going to perform them using the same principle and the same method that we applied here. If they say show that you prove, that means you have to check whether the left-hand side is equal to the right-hand side. But basically, if they say prove that the left-hand side is equal to the right-hand side, you have to check the complicated side, a very complex side. Then let's look at question number 2. Here I'm looking at the questions that I think as you can find problem based on them. Then let's look at number G. Number G, we're given 3. Wait, let me change the color. Not to be. Now the color blue. Then here we have 3 multiplied by 2 to the exponent x minus 2 to the exponent x minus 1 divided by 2 to the exponent x plus 2 to the exponent x plus 2. Then here we're going to say, remember I said when you see plus or minus, you take out what? You take out a common factor. In exponents, when you see plus or minus, take out a common factor. Then here we're going to say 3 multiplied by 2 to the exponent x minus this one. We're going to solve it using the principle that says if the b's are the same, we add the exponent. Then we're going to write it like this. Divided by, then below is b2 to the exponent x plus 2 to the exponent x multiplied by 2 to the exponent 2. This principle is that one. If the b's are the same, we add the exponents. Then we look at common factors here. The common factor is 2 to the exponent x. Then here we say 2 to the exponent x outside the bracket, 3 minus 2 to the exponent negative 1. Then here we have 2 to the exponent x in brackets 1 plus 2 to the exponent 2, which is equals to the like terms. If you divide and there's the values that are the same in the numerator and the denominator, they cancel each other. Then we're going to have something like 3 minus 2 to the exponent negative 1, which is equals to 5 over 2 divided by 1 plus 2 to the exponent 2 is 5. Then basically we're going to have 5 over 2 applying reciprocal times 1 over 5. So basically we get 1 over 2. Then this is our answer. 5 over 2 divided by 5, 1 over 2. That is our answer. That is where we came in. So basically, in terms of this question, as long as you have plus or minus in exponents, should know what you have to take out a common factor. Let's look at the number h. The number h were given 4 to the exponent x plus 2 to the exponent 2x minus 1 divided by 2 to the exponent 2x minus 1. I said immediately you see plus or minus, you do what? Take out a common factor, my dad. Then here we're going to be having for 4 to the exponent of x is equivalent to 2 to the exponent 2x plus 2 to the exponent 2x multiplied by 2 to the exponent negative 1. We apply that law that says if the bases are the same at the exponent, then here also the same law, 2 to the exponent 2x multiplied by 2 to the exponent negative 1, which is equal to, we take out a common factor of 2 to the exponent 2x, then we have 1 plus 2 to the exponent negative 1, then divided by 2 to the exponent 2x multiplied by 2 negative 1. Then here, the like terms, they cancels each other. Then we're left with 1 plus 1 over 2 divided by 1 over 2. This is equivalent to what? 1 plus 2 to the negative 1 divided by 2 to the negative 1, we get 3. Then this is our answer. I'm busy. Then let's look at the third question. The third question also, because they're dealing with plus or minus. So take in mind, remember, in mind, you have to think about taking out a common factor because it's plus or minus. So here we'll be having 2 to the exponent 2x minus 2 to the exponent x divided by 2 to the exponent x minus 1, which is equivalent to 1. Here, if you can check, we can take out a common factor because this is equivalent to 2 to the exponent of x multiplied 2 to the exponent x. Because if the bases are the same, we add the exponent minus 2 to the exponent x divided by 2 to the exponent x minus 1, which is equal to, we take out a common factor of 2 to the exponent of x, 2 to the exponent of x, which is 2 to the exponent of x minus 1, divided by 2 to the exponent x minus 1. Then these ones, they're the like times, they divide each other. Then we have an answer of 2 to the exponent x. Then this is our answer. Always like that. Remember, if you see plus or minus in exponents, we do what? We take out a common factor. Then number B, as you can see, is 2 to the exponent 2x minus 1. Immediately I write something like this. You know good, this is the difference of two squares. That is 2 to the exponent x plus 1 in the denominator is equivalent to what? Here is the difference of two squares because that is equivalent to 2 to the exponent of x squared minus 1 divided by 2 to the exponent of x plus 1. This is equivalent to 2 to the exponent of x minus 1, 2 to the exponent of x plus 1, divided by 2 to the exponent of x plus 1. This cancels that. Then we're left with what? 2 to the exponent of x minus 1. Then that was our last question. Remember, here you can see is the difference of two squares. It's like this is equivalent to a situation where you have x squared minus 1, which is equals to x minus 1, x plus 1. That is what this expression means. Then number D, do you have 16 minus 4x? Let me write it down. 16 minus 4 to the exponent of x. Here's 4, so you can see, divided by 2 to the exponent x minus 4. This is equal to, remember, 16 in the calculator equal to shift factor, you get 2 to the exponent 4. 2 to the exponent 4 minus 2 to the exponent 2x because of the 4 there, divided by 2 to the exponent of x minus 2 to the exponent of 2. Then here also is the difference of two squares, meaning we can solve it like 2 to the exponent of 2. Wait, let me see the question properly. Okay. We can solve it as 2 to the exponent of 2 minus 2 to the exponent of x and 2 to the exponent of 2 minus, plus here, 2 to the exponent of x. Because this multiplied this, it would be 2 to the exponent of 4. But if the bases are the same at the exponent, as I said, it's the difference between two squares. Then here we have 2 to the exponent of x minus 2 to the exponent of 2. So this is equivalent to 2 to the exponent of 2. Let me just write it as 4 minus 2x 4 plus 2 to the exponent of x. Then here we're going to make it somehow. We're going to say negative 4 plus 2 to the exponent of x. Then this is equivalent to 4 minus 2 to the exponent of x, 4 plus 2 to the exponent of x, divided by negative. We take it negative outside as a common factor, then we'll be left with 4 minus 2 to the exponent of x. As you can see, this and this cancels, but the answer is going to be is equals to negative 4 plus 2 to the exponent of x. Then when we simplify this thing, we're going to find negative 4 minus 2 to the exponent of x. Then this is our answer. As we're done with the homework, The homework, I think everything's fine because the reason why I'm saying I'm doing only few questions because this one is equivalent to this one. It's the same. We should be like in the same manner. And on top of that, if you can check, this one is equivalent to that one, and also equivalent to that one, and this one is equivalent to the other one. So, which means we apply the same principles. That's why I don't want to do all of them. So, let's go ahead and deal with roots and sets. Okay, roots and sets. The main thing that I got an interest on with this one is based on root definition. So here I came to realize over again, um, always if we're dealing with roots, for example, when we're dealing with roots, basically this is the principle of roots. This part we're dealing with mainly roots. So basically when we're dealing with roots, you should know what 1 over a number is always equivalent to a number and like this number and a root. So basically, every time we have 1 over, it generates into a root. Then from that instance, if we have a to the exponent of m multiplied by n, that means this number is going to be above the root, whereby it's n root of a m. So this is the principle that we're talking about. That's what we're talking about, the root definition. For example, let's take a look at a few examples. For example, you have to know how a root behaves. For example, we have a situation where we have 3 to the exponent of a squared. This thing, a squared, this thing is equivalent to a 2 over 3. Okay, fine. Let's talk about a situation where we have a root of a. This thing is equivalent to a 1 over 2. The reason why it's 2 is because the root alone, there is 2 here. It's just that it is being made invisible. Visible. You see, there is that 2 there, but don't write it. When you see a root, just see a 2. Then again, we can have a problem like a 2 over 3, which can be equivalent to, remember this one goes to this part of the root, then it's going to be 3 root of a squared. Then another example, we can have x 4 over 3 is equals to 3 root of x, or x, and exponent of 4, always like that. Those is when we're dealing with the roots, and you can move versa versa with them. That's why sometimes I was moving from here into a root. Sometimes I was moving from a root into this part of exponent. So let's look at sets. When we're looking at sets, we have, okay, let me read through before I go into details about explaining what is a set and a lot. So what is happening is when a root is irrational, it is referred to be as a set. So when we're talking about irrational, we're talking about it cannot be written, cannot be written as a fraction. Then there, we're talking about sets. Sets, when a root is irrational, is referred as a set, which means when we have a root that is irrational, meaning it cannot be written as a fraction, is a set. But the same in other ways. A set, let me try to zoom in a little bit. Now zoomist. Okay. Then they say a set is the root of a number that cannot be determined exactly. So basically, it's a root of a number that cannot be determined exactly. They just mean immediately you make a root of that number, it cannot be determined exactly because it will give you decimal values instead of a number. Example, a root of 2 is a decimal value, a root of 5 is a decimal value, a root of this is a decimal value, then it's a set. But root of 4 is 2, root of 36 is 6, root of cubic root of 27 is 3. You see, are not sets. These ones are not sets. Sets are those in which the root of that number cannot be determined exactly. It will give you something that we call decimal values. Then there are, as I highlight, I never used a highlighter, but let me try to highlight. This is very, very much important. This is there are I'm trying to highlight. Okay, let me just try. There are two set laws for A, which is positive, for B, which is positive, for N, that is greater than or equal to 2, for N, which is the element of natural numbers. The reason why they're saying A is positive and B is positive is to avoid something called non-real. Because a root of a negative number is equivalent to non-real. So from that instance, that's why we say A is positive and B is positive. So the first law says that is the two set laws or rules. Okay, so the multiplication law. The multiplication law says immediately you have the root that is the same, the root of a number, because this n represents a number. Number that can be greater than 2 or equal to 2. The reason why this is greater than or equal to 2, because the root, the number here is always from 2 up to infinity. There's no less than. Only from 2 up to infinity. Then this number 1 is the same as this number. That means this, and we have a number here, you have a number, you can multiply the two numbers in the same root. Or if you have a root with a number here, and or it can just be a root without a number there, because without a number is square. We prefer this part to be true. Can be a root there without a number, right? Or with a number. But the two variables inside, they're multiplied. That means we can break it down into this part, right? Then we have a division law. It says if we have a root, of the same feature, but the numbers inside might be different, then this thing you can just write it as one root and divide everything together. And we can shift from this part to that part. You see, we can shift from this part to that part. So that is the thing about sets. So let's look at few examples pertaining sets. Okay, let's look at few examples. Pertaining sets. Okay, example that relates to law 1. Example that pertains to law 1, we have root of 2. Oh, sorry about that. I tried to write and it made still that. Root of 2 multiplied by root of 3. Remember the root, they are one, but the only difference is what? The numbers inside. These numbers inside are the ones that are different, but the root are of the same feature. This is equivalent to root of 2 times 3, which is equal to root of 6. And this is what we just discussed when we're talking about this part of the first law, the multiplication law. Then again, we can have another example of law 2, the division law, that says if the root is of the same feature, meaning the number here is the same with the other number, 16 divided by 3 root of 2. Here, this thing can be written also as 3 root of 16 divided by 2. And 3 root of 16 divided by 2, we get 8. And cubic root of 8 is 2. So here's 8 is equal to 2. And that is our answer. You see? So let's look at bigger questions now. The questions pertaining sets, the questions which will enable you to apply the true definitions, but which are a little bit complex. For example, number 1, we got 5 root of 3 plus 2 root of 3 minus 3 root of 3. So in this situation, you can see where these numbers, they are the like terms. And in maths, if numbers are like terms, you can be able to add them, you can be able to subtract them. Then we're going to start by adding 5 root of 3 with 2 root of 3, which is equals to 7 root of 3 minus 3 root of 3. This thing is equivalent to 4 root of 3. Then this is our answer. Meaning sets can be added or subtracted, but only if they are like terms. We really want to know they are like terms in terms of the root, in terms of what determines the set. Because a set is a root of an irrational, basically is a root that is irrational. As we said here, set is a root, is irrational. Is when a root is irrational. So basically, is a root that is irrational. So from that instance, that is set. Then this part is a set. This part is a set. When the sets are the same, meaning we have to add them or subtract them because that determines what like terms. Okay, let's look at the second example. Second example, this is we have root of 12 plus 4 root of 75. The first thing that we have to do is the first thing that we have to do in terms of to these things is that you have to find with this 12, you have to find what makes the 12. Like go to your calculator and say 12 equal to shift fact, then you find 2 to the exponent of 2 multiplied by 3 plus 4, right? Then you go again into the calculator and say 75 equals to shift fact. You find 3 times 5 to the exponent of 2. Then in this situation, we know what a root of 2 squared multiplied by a root of 3 is equivalent to that, according to which law? The multiplication law of sets, plus 4, a root of 3 multiplied by a root of 5 squared. Here is going to be equal to 2 root of 3 plus here is going to be 4 root of 3 multiplied by 5, which is equals to 2 root of 3 plus 4 multiplied by 5 is 20 root of 3. Then this is equivalent to 22 root of 3. You see, that is how we solve this kind of problems. Then the other one, we might have a problem like root of 27 divided by root of 3. Remember this according to the division law. 27 is equivalent to that. Then 27 divided by 7, 27 divided by 3, I need to say. 27 divided by 3 is equivalent to 9. And we know that this is equivalent to 3. Then this is our answer. Then let's try to look at another question. So if you have also, number 4, let's see, 2 plus 3 root of root of 2 squared. This thing can also be factorized like 2 plus 3 root of 2, 2 plus 3 root of 2. Because this thing, this squared just means we have 2 times multiplied together, that are the same. Then 2 multiplied by 2 will be equivalent to 4. Then 2 multiplied by 3 root of 2 will be equivalent to plus 6 root of 2 plus 3 root of 2 multiplied by 2 will be equivalent to 6 root of 2 plus 3 root of 2 multiplied by 3 root of 2 is equivalent to 18. So this thing is equal to 4 plus 12 root of 2 plus 18, because these are like terms, then we add them. In terms of sets, they are like terms. Then we just add them. Then this is equivalent to 22 plus 12 root of 2. So those are the questions that I have for you in terms of sets. Then let's look at the other part. Rationalizing the denominator. The principle of rationalizing the denominator is to remove a set, a rational number in the denominator. So basically rationalizing the denominator, we just remove a set. So how are we removing a set? Remember for number A, For us to remove a set, if we can multiply this set by itself, we get 3. Then from that instance, we remove the. That's why we're going to say here multiply by 1. Then 6 root of 3 multiplied by root of 3 divided by root of 3. Then root of 3 multiplied by root of 3, we have 3. Then 6 divided by 3 is 2 root of 3. You see, those are the principles. So basically, rationalizing the denominator, we remove the set in the denominator. Number B, we have 8 3 cubic of root of 2 multiplied by 1. If we can multiply by this, 3 root of 2 multiplied by 3 root of 2, I mean cubic root of 2 multiplied by cubic root of 2 is not equal to a number that is not irrational. It will give you a number that is irrational. Then from that instance, we have to multiply by the denominator again. Then if we multiply by again, the cubic root of 2 multiplied by cubic root of 2 multiplied by cubic root of 2, we get 2. Then that means we have rationalized the denominator. So from here, we're going to say 8 divided by 3 root of 2 multiplied by 3 cubic root of 2. Cubic root of 2 divided by cubic root of 2 multiplied by cubic root of 2 divided by cubic root of 2. Then we'll get something like 8 cubic root of 4 divided by 2, which is equivalent to 4 cubic root of 4. Then here, this one, we're just going to say 5 over 4 minus root of 3 multiplied by 4 plus root of 3, because we want to remove the set in the denominator. Then this thing, after we multiplied everything, we're going to have 5, 4 plus root of 3 divided by 4 minus root of 3, 4 plus root of 3. Because this thing, when we multiplied it, it's going to give us a number that can be written as a fraction, because 13 divided by 1 is a fraction, right? Then from that instance, we're going to have 20 plus 5 root of 3. Then after we factorized this part, we're going to have 16 plus 4 root of 3 minus 4 root of 3 minus 3. Then we'll be having 20 plus 5 root of 3 divided by 30. Then we're done. Then let's look at exponential equations. In exponential equations, like is exponents being in a form of an equation, then we have to find the unknown. Then this is in an exponential equation, the exponent is unknown. So basically, when we're dealing with an exponential equation, the exponent is always unknown. We don't know what is happening to the exponent. Then, for example, consider the following equation. The rate of the exponent x is equal to 9. Then the equation can be solved as follows. You see, they found the exponential form of 9, which is 3 squared. Then because the bases are the same, we write them off and take the exponent and equalize them. You see, we equate the exponents, right? For example, let's look at a very complex example. We have 9 to the exponent x plus 1, which is equal to 27 to the exponent x. You see, this is not as simple as this. Then here you have to write the exponential form of 9, which is 3 squared, x plus 1, and the exponential form of 27, which is 3 to the exponent of 3, x. Then here we know we're going to multiply this 2 by x plus 1, then we find 3 to the exponent of 2x plus 2, which is equals to 3 to the exponent 3x. Then here we do what? We drop the bases and equate the exponents. Then we have 2x plus 2 is equals to 3x. Then we take the 3x on the other side, we'll be having 2x minus 3x. Then we take the 2 to the other side, we have negative 2. Then 2x minus 3x is equals to negative x, which is equal to negative 2. Then our x is equals to 2. This is our answer. So let's look at the last example. We have 2 to the exponent of x, which is equals to 1 over 16. Then 2 to the exponent of x, this one is equivalent to 1 over 2 to the exponent of 4. We know what if we write something in fraction form like this, meaning we can write this also in this form, 2 to the exponent negative 4. Then we drop the basis, then we equate the exponents, which is equal to negative 4. Then this is our answer. And remember, you can be able to prove these things by taking these 2 and substituting there, and take this 2 and substitute there. Then the number that you get from this side has to be equal to the number that you get from that side. That is it about today's sessions. We're looking at roots and sides, looking at rationalizing the denominator, looking at exponential equations. Then look forward to get a homework that you will do and send it to me via WhatsApp, then I will rectify it. That's it about today's session. It was short, and these things are very easy. I wish you best of luck. Remember, it's academic level up. The best online tutorial session provided.